Originally, this aircraft was born to respond to the pre-war specification of the Regia Aeronautica, which intended to equip itself with a heavy fighter. But then, in the fertile mind of its creator, it became an aircraft that could adapt to use the recycling of successful engines from previous generations, while maintaining its competitiveness as a heavy fighter, thanks to a decidedly good aerodynamics and a wise management of weights. In 1939, the Regia Aeronautica competition aims to equip the flight line with a heavy fighter, an aircraft that was missing in the Italian military aviation. To meet the requirements of the tender, Engineer Galasso, chief designer of Industrie Meccanische Aeronautica Meridionale of Naples, thinks of a twin-engine two-seater monoplane, entirely built in metal, with a light alloy body, equipped with flaps of the same material, the fuselage, a light alloy shell covered in duralumin sheet metal. The double-fin metal tailplanes with only the immobile surfaces in canvas. The fully retractable undercarriage, housed in the engine nacelles for the two main elements, while housed in the fuselage for the steerable tailwheel. The aircraft is designed to be powered by Daimler-Benz 601 engines of 1,175 horsepower each, driving two Alfa Romeo metal tribal propellers with variable pitch in flight. As for the armament, it consisted of three 20mm Mauser cannons installed in the bow fighter, to which, in some types of mission, two other weapons of the same type were added in a removable ventral pod. In addition to the cannons, the aircraft has a sixth weapon, a 12.7mm Breda Safat, available to the second member of the crew for rear defense. The aircraft was also equipped with ventral attachments for drop loads. Engineer Galasso and his collaborators, after having developed the project and created a wooden rock-up, arrived at determining and building a prototype of the aircraft, also taking advantage of the practical advice of Captain Adriano Mantelli, the pilot designated for the test, in particular regarding the optimization of the cockpit conducted on a wooden mock-up that allows for better management of present and future spaces and equipment. The Ro 58, despite having been built with limited means, using two original German engines used and overhauled, could be considered an excellent airplane in its genre. Even the modifications were inferior in number and importance to those that involved other famous war twin engines such as the P-38 or the Mosquito, just to name two, evidence of the great engineering wisdom of the designer and his group of collaborators. But specifically, let's identify which were the corrective interventions that were implemented. After the first flight of the prototype MM431 carried out at Capodichino in May 1942 by Adriano Mantelli, the failure of one of the engines was recorded, due to a rapid loss of efficiency of one of the fuel pumps. The Ro 58, brought back into flight, recorded new problems. In fact, it was extensively modified in the tail sector. The wake of the flaps was such as to remove flow from the tail planes, inhibiting their action. As long as Engineer Galasso had wanted to experiment with a fixed horizontal tail plane to increase the structural capacity to absorb deformations. Given the inefficiency of this solution, It was provided to equip the entire tail of the aircraft with a movement via an oleodynamic system, which moved the entire tail and placed it, when necessary, outside the area of the reduced fluid dynamic flow, solving by completely restoring the incoming flow on the tail planes. In practice, the tail planes had been made variable incidence, cutting the tail, hinging it at the high point and controlling it with a jack at the bottom. The modification was very quick, brilliant and safe. It ensured both the complete action of the tail planes and their structural function with the designed resistance to the flexural torsional moments calculated even for maneuvers at the limits of the maneuver diagram in combat. Furthermore, in order to correct a problem of aerodynamic interference between the fuselage, nacelles and wing, which did not allow the engine radiators to perform their task very well, so much so that the temperature of the engines quickly rose to critical levels. The radiators were moved to better areas where efficiency was totally guaranteed, so much so that the engines, which were salvaged, were tested, dismantling them after the hours of expected use on the RO-58, as well as in simulated combat, and after all the planned test flights, were not worn out, extending their operational life. Finally, a minor problem. The search for the best point of the outlet nozzle from the petrol tank, because the shape of the tank and the very strong acceleration during takeoff with a lack of fuel meant that the fuel accumulated towards the rear wall, uncovering the outlet button. This inconvenience was also quickly remedied. All the corrections achieved what was intended, so the aircraft left the Imam sheds completely resolved from the design side and ready for an intense cycle of tests at the DSSE in Guidonia, i.e., the Higher Directorate of Studies and Experiences. The aircraft was in Guidonia at the beginning of 1942, where a German mission arrived to visit with some new aircraft to compare with the new Italian aircraft. Single engine and twin engine. Among these the Messerschmitt 410 powered by two Daimler-Benz 603 engines of 1,750 horsepower each. The German solution to cover the same role that the RO-58 should have assumed. Therefore the Messerschmitt 410 had 1,150 horsepower more than the RO-58. Captain Mantelli was one of the few pilots who could test the Messerschmitt 410, and he got the impression that it was neither better nor faster than the RO-58. In a subsequent direct comparison between the two aircraft, the impression of the Italian test pilot was confirmed by the facts. The German pilots and engineers who examined and recalculated the test parameters of the RO-58 immediately expressed very positive opinions for the aircraft, especially on the setup, takeoff, landing, handling, which were perfect. The only thing that remained was the speed. Compared to the 1,750 horsepower Daimler-Benz 603 engines of the Me 410, the RO-58 was equipped with 1,175 horsepower Daimler-Benz 601 engines, which had been overhauled as best as possible. Therefore, the Me 410, on paper, showed a top speed higher than the Italian aircraft, at least 20 km per hour more than the RO-58. The Germans insisted on a speed test on a set circuit. That is, the classic dog race. General Cassinelli, who was the commander of Guidonia, was against it for fear of an unflattering outcome for the Italian fighter, but Galasso and his staff were confident and managed to convince Cassinelli. In the end, this test was also done. The two aircraft were compared on the circular route between the Gran Sasso mountain and Guidonia, flying side by side at full throttle. With surprising results, almost half a minute in favor of the Ro 58 piloted by Mantelli, despite the Me 410 being flown, equally, by a famous German test pilot. From mid-1942, engineer Caleri, a close collaborator of Galasso, was supported by Mantelli for the tests of the Ro 58 in Guidonia. The only problem that could be seen in perspective was that, if the aircraft was chosen for series production, of guaranteeing the flow of engines necessary for series production, given that in MID 1942, the DB601 was heavily absorbed in its production and revision, both for the original models and for those reproduced under license by Alfa Romeo. To equip what were still the frontline fighters of the Royal Air Force, namely the Macchi 202 and the Regia 2001, a real pain. But Galasso, during 1942, it was clear that, since all the frontline fighters of the fifth generation would have had either the DB605 or even the DB603, there would be a good quantity of DB601 or the similar one produced under license Alfa Romeo 1000. Quantity enough to ensure both the series and the maintenance replacements of the engines for the Ro 58, guaranteeing the efficiency of the flight line of this twin engine. Furthermore, it is to be noted that Galasso calculated that if the Daimler-Benz 603 had been available, instead of the Daimler-Benz 601, the Ro 58 would have touched 690 km per hour and considerably increased its general performance, with very limited adaptations necessary. It can therefore be deduced that the aircraft, being equipped with nacelles and castles and wing structure, easily adaptable to both the DB605 and the powerful DB603, had a good development potential for variants of various kinds, even equipped with heavier armament and radar equipment. Let us now turn to the technical characteristics of the Ro 58. It had a wingspan of 13.40 meters, length 9.89 meters, height 3.39 meters, wing surface area 26.20 square meters, empty weight 4,350 kilograms, maximum takeoff weight 6,100 kilograms, maximum speed 605 kilometers per hour at 5,120 meters, altitude, minimum speed 220 kilometers per hour, climb time 6,000 meters 6 minutes, tangency 10,500 meters, autonomy 1,500 kilometers. Engineer Giovanni Galasso. On September 3, 1942 and September 16, 1942, wrote two memos that responded to the usual exceptions and requests for modifications by the authorities that unfortunately slowed down the launch of many excellent aircraft prototypes, not allowing the rapid technological adaptation to the flight lines supplied to the Regia Aeronautica. Reference is made, in these memos, To the verbal request made on August 12 by the Superior Military Technical Inspectorate to examine the possibility of making the following modifications to the RO-58. Namely, the installation of dive brakes, increasing the supply of rounds of the two 20mm caliber weapons, and the addition of other rear armor in addition to that already planned at the time for the position of the second observer seat. Galasu wrote in the memos that the RO-58, in accordance with the technical specifications of the original tender, was designed for three 12.7mm guns at the bow and a 12.7 in second place, without a camera, without any armor, and with the explicit exclusion of bomb installation. However, in the project it was foreseen by Galasu with significant oversizing. The fuselage capacity and the margin for wing overloads were such as to allow the subsequent replacement of the three 12.7mm guns with two 20mm with a weight increase of 113 kg, as well as the addition of the camera, which involved 25 kg of weight increase, and the addition of the armor of the two seats, which involved 153 kg more weight increase. Furthermore, during the development phase he carried out tests with overloads and external bombs. The weight characteristics of the aircraft thus revised were approximately 4,300 kg of empty weight, 620 kg of military load, 170 kg of crew, 90 kg for the configuration with the three 12.7 weapons with supplies of 1,012.7 rounds, therefore 110 kg. If instead one opted for the two 20mm weapons for a weight of 69 kg of burden. For the collimator also weight of 3 kg, and one would have had an available load of 980 kg. To which add oxygen for 16 kg and gasoline for 910 kg, the total weight fully loaded with hooks and abutments for central bomb 4 wing bombs, but without bombs, would have been approximately 5,900 kg. Despite all this, the wing load was 226 kg per square meter. Therefore excellent. If it had been necessary to proceed with the application of the dive brakes, this would have led to an increase in weight of 100 kg, as well as an increase in resistance to advancement, something considered by Galasu to be simply crazy, both for the inevitable roughness that would have been introduced and that would have altered the aerodynamics of the aircraft, both for the inevitable delay in preparing the drawings of the aircraft of about 6 months, because it would have been necessary to study and apply the air brakes to the prototype, carry out the in-flight tuning of the thus transformed aircraft, and complete the wing drawings with the increase in the number of shots of each of the two weapons from the current 140 to the maximum 260 obtainable given the fuselage section. This modification would have entailed an increase of 65 kg. A shift of the center of gravity forward in the most unfavorable conditions of almost 4 centimeters. This last condition being particularly disadvantageous and inadvisable due to the consequences on stability and maneuverability. Furthermore, the delays in the fuselage designs would have been of about 5 months. Because in this too it would have been necessary to fine-tune the modified aircraft, given the importance of the variants. Galasu also wrote that the lower and rear armor as requested, with flat glass armor and lateral armor, would have led to an increase in weight of about 80 kilograms. And furthermore, the center of gravity would have moved back by 2.5 centimeters and would have generated a notable increase in resistance to advancement. In fact, each of the three arrangements, in addition to significantly altering the physiognomy of the aircraft and bringing the wing loads to excessively high values, would have led to making it difficult to use the Ro-58 to drop bombs of significant war value. On September 3, 1942, the second document, again by engineer Galasso for the Ro-58, stated, following the verbal request formulated by the Undersecretary to increase as much as possible the number of 20 mm hunting weapons of this aircraft, possibly completely abolishing the 12.7 mm machine guns, to have carried out a preliminary study of the problem. From this study, the possibility of installing two 20 mm weapons externally under the belly of the fuselage, in correspondence with the wing box within a detachable pod in which they could find, in addition to the two cannons, the two cassettes for 175 rounds each. The two weapons would have been placed on a tilting cradle to be able to carry out the normal maintenance operations of the weapons themselves. The cradle was housed in a body consisting of two well-started fairings, one at the bow and one at the stern, so as to obtain a shape with the minimum possible resistance. This arrangement also had the advantage of not altering the position of the center of gravity of the aircraft, also allowing for further development required in order to bring the capacity of the ammunition cassettes of the two 20 mm weapons existing inside the fuselage from 140 rounds to approximately 175 rounds. Therefore, the two 12.7 mm weapons could be replaced by a 20 mm weapon with a cassette of approximately 185,190 rounds, so that the armament in hunting can be made up of as many as 5 20 mm cannons with a total of 890 rounds. In this way, the weight of the aircraft compared to that indicated in the previous memo increased by approximately 200 kilograms and reached 6,100 kilograms. The wing load was increased to 232 kilograms per square meter, among other things without significant decrease in maximum speed despite the large increase in armament. Among other things, Galasso expressed satisfaction with the fact that the inspectorate had realized the validity of the answers given to the previous requests, for which the inspectorate had renounced the application of dive brakes and had realized the need to confirm the weight of the aircraft within the limits indicated by the designer, following the prescription that any addition of installations and weights, especially if far from the center of gravity, had to correspond to an equivalent reduction in weight of other installations already present. During a meeting at the Ministry of Aeronautics, the pure excellent Ro-58 was indicated as having a high wing loading, which is completely false. Just compare it with foreign counterparts to realize this. That the Messerschmitt 410 had a wing loading of 268 kilograms per square meter. The British Beaufighter 247 kilograms per square meter. The American Northrop P-61 even 269 kilograms per square meter of wing loading, while the Ro-58 in the worst of situations had a wing loading of 232 kilograms per square meter, which was by far the lowest among its direct competitors in the heavy fighter role from 1942 to 1945. And it was also claimed that the aircraft would require very experienced pilots, which was also completely false, as it was flown, to full satisfaction, by German pilots who had very limited experience of twin-engine fighters. Therefore, these statements released by high authorities of the Ministry of Aeronautics have no support from a technical point of view, but they brought a heavy burden to the aircraft that in the end was not adopted. In Guidonia, meanwhile, Mantelli continued to fly with Row 58 in preparation for a bombing mission on the formations of flying fortresses with bombs equipped with time fuses. The bombs were to be dropped from an altitude higher than that at which the Allied bombing formation would have flown, and then exploded inside the bombing package with a devastating action for the Allied formation, which, in addition to direct losses, would have been disorganized, becoming prey of the Italian fighter units mounted on Macchi 205. Regia 2005 and Fiat G55 that had been specially quartered at the airports of Capodichino, Capua, Centocelle and Ciampino, and that would have operated jointly with the Row 58 to implement this tactic against the Allied bombing formations. The action would have been carried out between the interception space of Naples and that of Di Roma. This action, which was also supposed to give the hoped-for results, was first postponed, and then cancelled due to the precipitation of events. It should be remembered that the idea was adopted by the Germans, who actually used it in the fight against the massive bombings in Germany by the Allied fleets engaged in the annihilation of German industrial and moral capabilities. It is interesting to note how in all these considerations, Engineer Galasso was guided by not exceeding the maximum structural takeoff weight, by the standard length of the runways available on the airports designed for the use of the aircraft, by the maximum temperatures of the presumed operational areas, by the maximum winds found in the presumed operational areas, and so on. Therefore, a design conducted with a package of highly respectable variables contemplated and which were all pursued and guaranteed. The provisions planned were also very ingenious in terms of ammunition and combinations of transportable bombs. To obtain the optimization of the centering and place the center of gravity in the range allowed by the maneuvering and stability calculations of the Row 58. A way of thinking about the changes dynamically with respect to the single type of mission that was being carried out, all in order to obtain moments compatible with the maneuvering and load and stability diagrams of the missions planned for the aircraft. Also considering the possible maneuvers within maneuvered combat, as a heavy destroyer fighter both day and night, and for the high-altitude bombing of enemy bombing formations. To this end, various load sheets were prepared with provisions and ammunition and bombs of different types of drop allowed for the various uses, various release altitudes, types of enemy reaction encountered in flight. Also very interesting is the series of diagrams of the wing and fuselage flexures, as well as the shear and torsion diagrams, generated by the static and dynamic tests, which demonstrated both the structural quality of the project, even against high-performance single-engine aircraft such as the P-51 Mustang, It is worth noting that engineer Galasso was thinking of a pressurized variant of this heavy fighter which, given the performance characteristics that were expected to be ensured, would have made it possible to use it even against the Boeing 29s, which would only be in service in 1945 and of which absolutely nothing was known in 1942-1943. In this configuration, the aircraft was designed to mount more performing engines than the Daimler-Benz 603. Above all, they could be used at altitudes above 15,000 meters and with power sufficient to ensure cabin pressurization. To this end, engineer Galasso interacted with engineer Casaraghi of Piaggio, who in the meantime had acquired very in-depth knowledge both in the United States and in projects developed in Italy on the pressurization of military aircraft, or paste text to be read here. Thanks for your attention. See you at next video.